All right, class, so this is 10.6, and boy, by this time we're probably pretty used to the distance learning. You know, I'm recording this ahead of time, and I'm hoping by now maybe things are back to normal. We will see. Anyhow, here's 10.6, graphing the tangent, cotangent, secant, and cosecant. All right, these last few lessons are going to be challenging, so you're going to have to really focus in. Watch the quick review videos. Go on www.afterschoolhelp.com for additional help. Read the lesson in your book. All of these really important. All right, let's get into the lesson, graphing the tangent, cotangent, secant, and cotangent. All right, so first off, let's think about the period of the tangent function. So what is the period of the tangent function? And we've talked about this before. You may not remember, but it's 180 degrees. So this is different from the sine and cosine, right? The sine and the cosine, the period is 360. Again, the length of one full wave. So when you're talking about radians, that would be pi radians. Pi radians. Now, when you talk about the tangent and the cotangent, we got to talk about asymptotes. Asymptotes, those lines that the graph approaches but does not reach until infinity. And the key to understanding asymptotes is understanding what the tangent is. So when I say what is the ratio of the tangent, I hope everybody in their head says it's the opposite over the adjacent. Opposite over the adjacent. Well, in a trig function Cartesian plane, the opposite is the y, the vertical, and the adjacent is the x. So it's y over x, y over x. So let me show you what I mean. Let's come over here, take a look at this radial view here. Let's do a 45-degree angle, right? 45-degree angle. The tangent of 45 is the value of the opposite, right, which would be y, over the value of the adjacent side, right, which would be from here to here, which would be the x. And for a 45-degree angle, y is going to equal x, and so you get anything divided by itself is 1, and the tangent of a 45-degree angle is 1. All right, so, but notice here, and if I did the point here, right, this would be the x-coordinate of that point, and that would be the y of that point right there. So let's look at the point of 0 degrees, or 360 degrees. 0 or 360. All right, I'm ahead of myself here. Not 0. Let's take a look at 90 degrees, right? 90 degrees. So notice our x is 0 and our y is 1. So at 90 degrees, when you come over here, now let's look back over here again, your y is a 1 and your x is a 0. So do you see you have a 0 denominator and therefore infinity, and therefore we have a situation. So what are we looking for? We're looking for values of the tangent when the x is 0. So that happens here. This was 90 degrees. Where else does it happen at? And I hope you looked here and said it also happens at 270. So we have asymptotes at 90 and 270 degrees. So it's important that we understand that going forward. So let me come in here and let's stick in some asymptotes. I'm going to do them in purple. So we have an asymptote at 90, and we have an asymptote at 270. Now, because of coterminal angles, we can also go backwards 180 degrees from that 90, and we also have an asymptote at negative 90. If we kept going forward from 360, there'd be an asymptote at what, 450 if we were going that far out. So we're going to graph the tangent. All right, so first off, we are going to go backwards from negative 90 forward to not positive 90. You might ask, why do we do this? Okay, so we need a restricted domain. A restricted domain. So this goes all the way back to have an inverse, you need to have a one-to-one correspondence. To have a one-to-one correspondence, you must pass the horizontal line test. So to have a restricted domain, we have to pass the horizontal line test. So our restricted domain is right in this window, from -90 to 90. So what is our restricted domain? From -90 to 90. That's going to allow us to pass the horizontal line test and be in one-to-one correspondence. Now, if we were talking about radians, that would be negative pi over 2, right? 90 to positive pi over 2. So negative pi over 2 to positive pi, I wrote 9 there for the 90, positive pi over 2. All right, -90 to positive 90 is our restricted domain. Okay, so we're going to take our calculator out and we're just going to do our calculator, right? We're going to sub in to our variable and we're going to put in the degrees and we'll see what we get. All right, so first one, let's go ahead and do, whoops, I'm going backwards here. There we go. Let's go ahead and sub in -90 degrees. So hit tangent of -90, tangent of -90. All right, and hopefully your calculator says something like syntax error, domain error, etc. Well, we already know what -90 is, right? It's infinity or negative infinity. Okay, no problem. Next, go ahead and punch in -45. And your calculator should have told you -1. Okay, so where is -45? Right there. And at -45, we are at -1. So we're going to plot that point. All right, punch in -30, and you get -0.5774. All right, we're not going to plot that, but I'll show that to you in just a little bit. Really, the ones in the blue box are the key points of the tangent. And so let's go ahead and do 0. Punch in 0 degrees or 0 radians, and you get 0. So let's plot that point, 0, 0, right there. All right. Positive 45, punch it in the calculator, you should get 1. All right, and again, positive 45 is right there, so we're at 1, and punch in pi over 2 or 90 degrees, and you're going to get positive infinity. All right, so here's the curve. We're going to approach the asymptote down here at negative infinity, and we're also going to approach the asymptote up here at positive infinity. So our curve goes just like this. And arrows on both ends. All right, there's our tangents. Got it? And that's the pattern. Now, you know, if you were to do 180 and 270, you're going to find out some similar things. But look, I can replicate this pattern over the next period right here, right? And if I wanted to, over the next period out here, etc., etc., etc. So, at the beginning of the period, we're at negative infinity, somewhere down here. Halfway, or quarter of the way through, right, we're at -1. Halfway through, we're at 0. 3/4 of the way, we're at +1. And toward the end, we end up at positive infinity. And there's our wave again. And now we just graphed it from -90 to 270. We could keep going, but that's the pattern. And so really the key is, there is the graph of the tangent function. And again, our restricted domain is from -90 to 90. Now that I showed you two waves, do you see how you fail that vertical line test if you keep going? Because again, we don't know which inverse to get back to if there's more than one horizontal line or point along a horizontal line. Okay, so for this reason, because the tangent approaches asymptotes, and because you can't draw it continuously without picking up your pen or pencil, we're going to say that it's a discontinuous function. Discontinuous. That makes sense, right? It does not continue. It's a discontinuous function. It does not continue due to the asymptotes. And therefore, how do you say the domain? Well, it's all the real values except x cannot equal. And yeah, we just got to do all the possibilities. So we're going to go plus minus 90, plus minus 270. See how these are the asymptotes? And the asymptotes will come every 180. So plus minus 270, 370, what is that, 450. And we can now go dot, dot, dot because we've established our pattern. So it's all the real numbers except positive and negative 90, positive negative 220, 270, positive negative 450, etc., 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 etc. Okay, that is the tangent function. Let's do one with a different period. Okay, so in this one, notice that we have the period of 3, so 3b. So now we got to think about what does that period mean with a 3b? What does that mean? And so we have to understand that the period, right, the period is now 180 divided by that 3, or 180 divided by the b value. And so the period of this first wave is going to be 60 degrees. And again, I'm doing it in degrees because your brain works a whole lot better in degrees than it does in anything else. How about this second one with a 2/3? Well, again, normal period is 180, and we've got to divide that 180 by that multiplier of the angle, that 2/3. And so we're dividing by 2 and we're multiplying by 3. So divide by 2 is 90, so 90, 180, so this would be 270 degree period on that one. So we have a change now in the period of the wave, the length of one wave. And so in the first one it's 60, in the second one it is 270. All right, so let's go with the, okay, so now that we know that, let's go ahead and graph y equals 1/2 tangent A. All right, so we're not going to graph those. Those are trickier and those are for another time. But we can change the amplitude, right? And I hope you caught that. I hope you caught the 1/2 as a change in amplitude. It's a multiplier. So how does that affect this? All right, well, we have no period change, so we still have our asymptotes at negative 90 and positive 90, all right? And we're going to do 2 waves on this one, so we'll go all the way to 270. Okay, so all I need to do is just do my calculations like before. So I punch in tangent of negative 90, I get infinity. Guess what a half times infinity is? Infinity, and again, this is negative infinity. So we're at negative infinity down here. Okay, at negative 45, well now when I would have gotten a negative 1, it's going to be negative 1 times that half, or negative 1/2. So now at negative 45, we are at negative 1/2, so we're there. 0 is still going to be 0. Punch in 45, so again, what you're doing here is you're punching in tangent of 45, and then you have to multiply by 1/2. And so you're going to get 1/2. There's 45 right there, and you're at 1/2. And then when you punch in 90, you're at infinity again. So notice what happened to the wave. It just kind of scrunches it up some in the middle here. Looks very similar, but that amplitude has changed. And we can just repeat it in that next window here. There's the first quarter. It's at negative 1/2. Halfway, it's at 0. Third quarter, it's at positive 1/2, and it ends up at infinity. Again, this is what you want to get in your brain, the pattern down. And that's the pattern you're thinking of for the tangent. So let me recap. Let's go back to the original and look. Here's the way you want to be able to figure out the tangent. It starts at the asymptote at negative infinity. At the first quarter, it's negative 1. At halfway, it's 0. At the third quarter, it's positive 1, and it ends up at positive infinity. That's the picture you want in your brain of the tangent function. All right, so that's the tangent. What about the cotangent? So the cotangent, you got the same scenario going on. You still have a 180 degree period, or pi radians. Where are we going to have asymptotes here? Okay, well remember, the cotangent is the adjacent over the opposite, right? The adjacent over the opposite, or in a Cartesian plane, it's the x divided by y. So now, when is the y 0? And you can see a y is 0 at 0, and a y is 0 at 180. So where are our asymptotes for the cotangent? At 0 or 180 degrees, and 180 is pi radians, 0 is 0 radians, right? Okay. So now we have to understand the cotangent and see what takes place. And again, you can just, the first time you can do this XY chart, but understand where our asymptotes are. They're at 0 and at 180. So now when I do my XY chart, I want to start at 0. So go ahead and punch in 0. Okay. So also now we have to understand how to do the cotangent. All right, remember, the cotangent equals 1 over the tangent. 1 over the tangent. And how do you get back? How do you get back from there? You have to go tangent to the -1. Yeah, 1 over the tangent. Let me think this through for a second. Yeah, so all we want to do is just sub in. Okay, so let me show you what I mean here. Do these first few. So the 0 would be 1 over the tangent of 0. So the tangent of 0, so we're doing 1 over the tangent of 0, so punch in tangent of 0. You get 0, and what's 1 divided by 0? See, there's your infinity. And this one is negative infinity. I'm sorry, positive infinity. All right, positive infinity. So we're going to be somewhere, I don't know, I'm going to go up in here. All right, second point now, and we want to do quarters, right? So we're going to do 45, 90, 135, and 180. So now 45, so it's 1 over the tangent of 45. Tangent of 45 is 1. 1 over 1 is 1. And so at 45, we're at 1. Right there. Okay, now we're doing 90. So again, it's 1 over the tangent of 90 degrees. Tangent of 90 degrees is tangent of 90 is error, and this one we have to figure out a different way. 1 over the tangent of 90. Let's go back to our radial view here. So 90 degrees, let's go to x, whoops, sorry about that, and y. So remember, the cotangent is x divided by y, so we get 0 divided by 1. What's 0 divided by 1? 0. All right. All right, so this is what happens with the trig functions, and this is what happens when you're dealing with some aspects of the trig function. So we had to go a different way to come up with the cotangent of 90 degrees. All right, 135, 1 over the tangent of 135. So punch in your calculator, 135. Hit the tangent button. Tangent 135 is -1, so 1 over -1 is a -1. And so we're right there. And do you see what's happening by now? And then finally, you're going to be at negative infinity at 180. And look what happened to the wave. It just flipped directions. And it moved 190, right? So there's your cotangent wave. So what you need to remember on this one is at the start, it's 0. At the first quarter, it's 1. Halfway, it's 0. At the third quarter, it's -1. And at the end, it's, that should have been negative infinity, right? Negative infinity. Okay, so again, I can do one more here. Positive infinity. At the first quarter, I'm at 1. Halfway, I'm at 0. Third quarter, -1. And I end up, going to go right in it. Whoa, that was interesting. I went right into my webcam, and that's what happened. All right, cool. All right, so anyhow, coming in through here like this. Let me draw at least that time. And there we go. All right, tangent, cotangent. We still got a cosecant and a secant to deal with. All right, what about the cosecant? So we got to remember the cosecant is the reciprocal of which function? Which function? Cosecant. Hopefully you're thinking the sine function. Okay, well our cosecant is also going to have asymptotes. So let me do it this way. The cosecant of x equals, all right, so now we got to remember, what is the sine? It's the opposite over the hypotenuse. What is the opposite? The opposite is the y. What is the hypotenuse? It's the r. So do the reverse. So this is going to be r over y. Now r is always positive. Always, right? The radius is always positive. So our concern is, when is the y 0? When is the y 0? This is what we're concerned about. When is this 0? All right, so let's just do a quick radial view. Forgive my circles, you know I'm terrible with those. Okay, so let's just do each point here. So point, the x here is going to be x, and the y is going to be 0. Okay, so there's the answer right off the bat. We got an asymptote of 0, and then that tells me over here as well, our y, our vertical change is 0, and this is going to be x or negative, whatever the value of x is, right, is 0. Okay, so we have asymptotes at 0 and 180 degrees. So let's put those in. Asymptote at 0 and asymptote at 180. Now this is really cool. The pattern here is a little bit more interesting in my estimation. So I have graphed the sine wave. So what's here is your sine wave. You might say, well, why did you graph the sine wave? Because the cosecant is the reciprocal of the sine wave. And if you'll do the sine, you'll be able to marry these two together. Okay, so what I want to do from here on out is to help you understand how we get the values that we're going to get. Okay, so let's deal with some aspects here of the sine wave. All right, so remember, the cosecant of x will equal 1 over the sine of x. Okay, so I'm going to do some values in here and hopefully help you to understand. And I'm going to first off do the cosecant of 90 degrees. So that should be 1 over the sine of 90 degrees. So just take the sine of 90 and then do the reciprocal. Well, sine of 90 is 1. So what's the reciprocal of 1? 1. So there's our first one. I'm doing it in blue here. So that's our first point, 90 and 1. Right at the crest of the sine is the cosecant. All right, let's go ahead and do, let's see what I have marked off here. Let's go ahead and do 45. So the cosecant of 45 is going to be 1 over the sine of 45. Now we could get this exact because of 45, 45, 90, but no need. Just do the sine of 45, which is 0.707, and then hit the reciprocal. And it's 1.41. 1.41 approximately, right? So 1.41 is going to be somewhere, whoops, That should be a little lower here. Let's see if I can move it down a little bit. Boy, I'm not very responsive here. Great, who knows what just happened there. I'll just put it in again, right about there. Good enough. Okay. And I'm going to do cosecant of 135, right? That's that value right there. So that's going to be 1 over the sine of 135. And if you catch on, it's symmetrical. That's 1.41 again. And what is the sine of the cosecant of 0? It's infinity. And what is the cosecant of 180? It's infinity. And here's how this portion of the wave goes. Just like that. Now you might think, okay, we've got the whole, that's how the cosecant goes. Well, no, not really. There's a little bit more involved here. I'm going to get rid of this. Sorry about popping that up. But I got to get to my menu so I can scroll down, and it's not letting me. And let me try another thing. This thing's been working goofy today. And let me try this. Great. All right, hang in there, class. I'm over at my keyboard right now. Let me get rid of my 3's. All right, try my Windows button, see if that will get rid of all that. Yes. Oh, now it's back again. Go away, please. Grab that quickly. Go away, please. Grab it. Oh, why is this coming up? All right, sorry about that. That's what happens. So now let's go ahead and I'm going to do it in green here. Now let's do this next section right in here. So we're going to have another asymptote every 180 degrees. So we're going to have one at 360. So I'm going to do the exact same thing. I'm going to go to the middle first. And once you know the pattern, you'll understand how to do this. So I'm going to go cosecant 270. So that's 1 over the sine of 270. Punch that in. Hit your 1 over button. You're going to get -1. That's that point right there. And so now it's back up here. So what is that? That is 225. So what is the cosecant of 225? That's 1 over the sine of 225. You can punch that in. You're going to get -1.41. So that's right about, it's 1.5. It's right about there. I was actually a little bit low my last time, no problem. Cosecant, let's do 315, which is right there. 1 over sine of 315. And again, we're -1.41. And again, we're right about there. Okay, so notice the wave is down here as well. And this is what you have to understand. This is one wave. Now, continuous or discontinuous? And I hope you think discontinuous. That is one wave from 0 to 360. All right, we're doing the cosecant, and so therefore our domain is 0 to 360. One full wave, 0 to 360. Okay, let's go ahead and finish off with the secant. It's the same idea. So watch, I'm going to do this one the quick way once you understand. The cosecant is the reciprocal of the cosine, right? Reciprocal of the cosine. So, let's again think about the secant. If the cosine is the adjacent over the hypotenuse, the adjacent over the radius, right, over the hypotenuse, then it's the radius over in the adjacent is the x value. So when is the x 0? So, all right, so one more time. I should have done the axis first. All right, worked out. So here you get x and the y is 0. So we're not concerned about that point. But what happens here? The x is 0 and the y is a value. So there's one asymptote, right, at 45 degrees, or pi over 2 radians. And where's the other one? Right down here, right, where the x is 0, and you get y. And so the other place is 270 degrees. So watch what happens when we drop in our asymptotes at 45, right there. 45. And at 270, something's off here. All right, we'll figure it out. Because it's not 45. Oh, brother. You know the brain sometimes. This is 90. Right? Which is pi over 2. That part was right. Not 45. All right, brother. All right. Sorry, guys. This is real life. Can't drink the Kool-Aid. All right. You know, this is what I was looking for. See that intersection right there? Again, the green dotted line is the pattern of the cosine. So this is the cosine of x. And it's the pattern. And the secant's going to do exactly what the cosecant did. So let me do this. Let me get rid of that. Let's leave that there. We'll leave those circles. So watch. See that peak right there? I'm going to match that point. I'm going to head this way toward infinity. I'm going to head that way toward infinity. I'm going to match that point. I'm going to head that way toward infinity. I'm going to head that way toward infinity, right? Do you see how that works? So, and again, I can back up here. I'd have that point. I'm heading up toward infinity. I'm heading toward infinity. So what you want to do to graph the secant is graph the cosine and put in an asymptote everywhere where the cosine is 0. Those are your asymptotes. Go to the crest or trough of the wave. There's the crest. And go up to infinity on both sides. Go to the trough. There's the trough. Go up to or down to infinity on both sides. There's the crest. Go up to infinity both sides. How do you do the secant? Graph the corresponding sine. Again, put the asymptotes everywhere. Oops, that jumped on me. Everywhere where the sine is 0. See where the sine is 0? Because, again, the cosecant is 1 over the sine, 1 over 0. So you get these asymptotes. Go to the crest, put a point, go up and up. Go to the trough, put a point, go down and down, etc., etc. This is how you graph the cosecant and the secant. All right, challenging, tricky. I understand all that. It takes a little bit of practice, and hopefully as you do, you'll get better at it. But that's the tangent, that's the cotangent, that's the secant, and that's the cosecant. All right.